In this video for lesson 1.7, we're going to be looking at finding arc measures, a couple more circle definitions, and then just doing some sketching. So finding arc measures, the measure of an arc has to do with the measure of its central angle. And I apologize, these should have little arc marks. Just like when we write the measure of an angle, we write M angle whatever. When we write the measure of an arc, we put an M in front of it, and that's how we indicate that we're talking about the measure of the arc, not the actual arc itself. This is different than arc length, which we will go into in depth later. So the measure of the arc really has to do with the amount of rotation from the first endpoint to the second endpoint, and that directly corresponds to its central angle measure. So angle measure, as we said, is the amount of rotation between one of the rays and the other. So I want you to look at your vocabulary sheet. We have minor arc BC here, and its measure is 45 degrees because if we look at angle B, well, let's just call this O. If we look at the measure of angle BOC, that is also 45 degrees. And so again, that's measuring the amount of rotation. For a major arc, it's the same idea, but the central angle, remember, is always measured in degrees that's less than 180. So a major arc is technically considered the reflex measure of the central angle. The central angle being the two endpoints of the arc connected to the center as the vertex, but again, a measure goes between 0 and 180. Because a semicircle produces a straight line, it's a diameter. A semicircle has a measure of 180 degrees. And I think that also makes sense because if a circle is 360 and it's going halfway across the circle, 360 divided by 2 is 180. Let's look at our picture over here. Use the circle to find the measure of the arc in the figure to the right. So the measure of arc QR. So here is arc QR. And if we look, the central angle associated with arc QR is angle QOR. And that has a measure of 48 degrees. And so the measure of that central angle is 48 degrees. So I'm going to write that in there. Then I want us to find the measure of arc PR. Here is arc PR. How could we find this measure? Well, we know that QP is a diameter, so that has a measure of 180 degrees, which means the measure of semicircle QRP, I meant to put that in red, has a measure of 180 degrees, and similar to angle addition or subtraction, if we take 180, if this whole arc is 180 degrees, if we subtract off the piece that we already know, we can go ahead and get that the measure of arc PR is 132 degrees. What is the measure of arc PQR? PQR. That's a major arc, so it's going to have a measure over 180 degrees. And in this case, it would be 180, which would be the semicircle from P to Q, plus the additional 48 degrees. And so that would be 228 degrees. And let's call this arc RPQ. So the measure of arc RPQ we could either get by adding 180 to 132, or we could subtract 360 and 48, however you wanted to think about that. I'm going to do a subtraction. And that would have a measure of 312 degrees. Some additional definitions that go with circles. What we have is the idea of something being inscribed or something being circumscribed. And these definitions are related. It depends on who's on the outside and who's on the inside. When we are circumscribed, when we talk about being circumscribed, that is the shape that is going around on the outside, okay? So if we are circumscribed about a circle, this polygon is circumscribed about a circle because it is outside the circle. And the definition of that is having all sides tangent to the circle. So as you can see, this polygon, this is a quadrilateral. It has 4 segments, 4 sides, and each side touches the circle at one point. So it is tangent. But we could also have the circle on the outside. And so when we say it is circumscribed about a polygon, what that's telling us is the circumscribed shape is a circle and the inscribed shape is a polygon. And so the circle this time is on the outside. And so the definition would be having all sides passing through each vertex. And so this case, it's the vertices of the polygon that is touching the actual shape. You can actually have other polygons being circumscribed about other polygons. So for example, you could have a rectangle circumscribe a parallelogram, for example. Although we most often talk about circumscribed and inscribed pertaining to circles and polygons. So inscribed is the reverse of that. If I have a circumscribed quadrilateral, it's an inscribed circle. And if I have a circumscribed polygon, if I have a circumscribed circle, it's an inscribed polygon. So here is my circumscribed circle. The circle is going around the polygon, and so that means it's an inscribed quadrilateral or an inscribed polygon. The polygon is inside. The circumscribed polygon becomes an inscribed circle. So a circle that intersects each side of the polygon once, the circle this time is inside. Let's go to some sketching. We want to sketch a circle with an inscribed pentagon. So I'm going to start with the circle. That's actually the easier piece to start with. And an inscribed pentagon means the pentagon is inside. And so all I'm going to do is draw something with 5 sides where each of those sides touch the circle. And I haven't given any labels to this circle or pentagon, so this would be enough. Okay, let's look at the next one. Using your compass and straight edge, draw circle O with diameter AB and tangent line CB. What appears to be true about angle ACB? So I don't have a compass or a straight edge, but I do want you to use your compass and straight edge so that you can get the most accurate picture that you can. Drawing, remember, is more accurate than sketching. So we're going to first draw circle O, and when you do that with your compass, what I suggest is you start with a point that is going to become your center, put your stylus on that, and then swoop your pencil around to get the full circle. And it's circle O, so we're going to label the center O. Now we're going to draw diameter AB. So then you're going to take your ruler and you're going to put it so that it passes through point O, and then just go ahead and use your straight edge to create a diameter that goes through that center, and the endpoints are A and B. And then we're going to draw tangent CB. Because I'm using the point B a second time, that means I would use the same point B as indicated in my original diameter. And this is kind of a little bit trickier. So take your straight edge and line it up so that it intersects point B. And again, try to line it up so that it only touches one time. It only touches at point B. Do that. And then it's line CB, so I have to pick another point somewhere. and label that point C. And then our last question is, what appears to be true about angle ABC? So here it is, angle ABC, ABC. What appears to be true? If you want, you can take your protractor, but it appears to be 90 degrees, which, as you guessed it, we will come back to later. I keep saying that. All right, for our last one, again, this is part practice using our tools, but also part idea of observation and putting things together. Use your compass to construct two circles with different radii so that they intersect in two different points. Place the center point, take your compass, put the stylus on the center, and rotate around to draw your first circle. For your second circle, we want to, again, use a different radius. And so I'm going to just pick a point out here, and I'm going to make this circle smaller. And I'm going to go ahead and put my stylus there. Now that does not look like the center, so I'm just going to adjust that and pretend that the center was here. And I'm actually going to adjust this one as well to pretend the center is here. So mine is more accurate, kind of retrofitting the accuracy. So we're going to label the centers P and Q and the intersection points A and B. And now we're going to go ahead and draw a quadrilateral PAQB. Take your straight edge, connect P to A to Q, Q to B, and B to P. And then what type of quadrilateral is it and why? This is, again, practice for observing, making connections between the different foundational layers that we have laid, and then also explaining. So what we have here is we actually have a kite. And why? We have two sets of consecutive congruent sides, and that's the definition of a kite. How do we know? Why? We know that AQ is congruent to QB because they are both radii of circle Q. And then we also know that BP and AP are congruent because they are both radii of circle P. We know radii are congruent in the same circle. I'm really squishing it in there. And so that was a great way to end, just drawing some conclusions, connecting to some other lessons. Please try the Chapter 7 homework. It's going to give you some more practice with this new vocabulary. And great job finishing Chapter 1.